So we have a CP test now. So let us open the CP test. Let me log in. Okay, so factors and factorial. So this was the problem which was given. Let us see what this is. So yeah, coming to the problem. Okay, let us read first. The factorial of a number n, written as n factorial, is defined as the product of all integers from 1 to n. It is often defined recursively as follows. So 1 factorial equal to uh, 1 factorial equal to 1 n factorial. Sorry, 1 factorial equal to 1, n factorial equal to n into n minus 1 factorial. Yeah. So factorial grow very rapidly, whereas 5 factorial equal to 120 and 10 factorial equal to like 36,020, 36 lakhs 28,800. Yeah, one way of specifying such large number is by specifying the number of times each prime number or prime factors occur in it. Thus, 825 could be specified as 0, 1, 2, 0, 1. That means no twos, no twos, 1, 3, 2, 5s, 0, 7s, and 1, 11. So let us calculate. So what is the factorial of 825? 825 factorial, which number gives 825? 5 factorial is 120. 6 factorial is like 6 to 12, 6 1 6, 720. I don't know how we can get this 825, but let us see. So 825, we said like 0 twos, 1 3. Okay. So that is 3, 3 into 2 5s. So 5 5 is 25 into 3, which gives us 125. 125 into 11. Yeah, 125 into 125, 125 into 11, we get 125, 125, 1375. Okay, let us use some calculator maybe. So there are like 111, 2 5s, 1 3. So 2 3s, 1 5, and 111. So which is giving us 425, but here it's presenting 825. 1 3 2 5, sorry. Like that. So good. Whatever. Yeah, 825, which is right. So okay. So any will be given a factorial. So and we need to represent its solution in number of prime numbers that can be represented. So write a program that will read in a number n and write out its factorial in terms of number of primes it contains. So so first of all, we need to find out the factorial of the given number and converting the given number into prime factors. So yeah, that's an easy thing, but there are few issues if we follow that order, that approach. The first one is like maybe if we were given like 100 factorial, so the integer can't store 100 factorial, so we need to find some other way. Uh, so we need counts, prime counts. So if we were asked 100 factorial, for suppose here given the 5 factorial, let us think 5 factorial can be represented as 5 into 4. 5 factorial can be represented as 5 into 4 into 3 into 1. Yes. So 4, 3, so 5, yeah, 5, 4, 3, 2, and 1. But if you observe, there is no need for us to multiply all these things. Okay, so we need some solution, so which is 120, but this 120 is not required, but we need the counts. So counts means like how many twos? 1 2, 1 3, and 4 can be represented as 2 into 2, like 4. So 2's count will become 3, and there won't be any 4 present because it's not a prime number, and 5. So 3 1 0 1. So 5 factorial, yeah, I think this is the answer. So like 2 into 2 into 2, 2 to 4, 4 to 8, 8 into 3, 8 3 is 24, 24 into 5, yeah, which is 120. So this is the answer I need to get. So which is I felt now it is easy because I will put a array list So whereas I will put all the numbers 1, 2, 3, 4, 5. So whenever it is a prime number, I just calculate its count as 1. And if it is not a prime number, I will try to find out its prime factors and increase the prime factors count in the remaining indexes. Okay, so that means I will put like these are the so here we need to use two arrays. So one is to keep track of 5, 4, 3, 2, 1. One is to keep track of the counts. Maybe we can do it like this. So the indexes will represent the thing. So indexes will start from 0, 1, 2, 3, 4, 5. Okay, and 0, 1 are not required. So initial counts are these one. So 0, 0, 0, 0 are the initial counts. So for 2, 3, 4, 5. Okay, starting with I will take I need the multiplication of these all things. So 2, 3, 4, 5. But in order to that, we need to calculate the primes. So in 2, 3, 4, 5, 2 is prime. So I can increase the count of 2 here, and 3 is also prime. 1, 3. For 4, this count will be 0 because 2 can be represented as prime numbers. So product of prime numbers as 2 into 2 prime factors in terms say. So 2 into 2, so 2 count will increase like this, and 5 is also a prime, so I can put it like this. This is the initial thought that come into my mind. So 311, 311. I'm getting a call. So hello, 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 Randy. Not interested in the requirement. Thank you. Hello. లేదండి. Thank you. Yeah, so they called for some housing loan, it seems. So okay. So, yeah, phone. Okay. So maybe initially I thought of doing this process. I don't know it will work or not. So for 5 it is working. Let us see for 53 also. We will cross check that. Okay. So for this to do this, I require two things. Whether to find this index is a prime number or not, so that I need not find the prime factors for that. And if it is not a prime factor, sorry, if it is not a prime number, I need to find the prime factor. So for 4 is not a prime number. I need to find the prime factors for that. And for 2 or 3, those are prime numbers. No need to for me to find the prime factor. So I need two initial functions. So first one is like prime is prime, and find out the prime factors. So let me write it down. So first of all, I write the prime is prime. So is prime. I will pass the n. Yeah. So for is prime, so every number which is less than 2 is not a prime. So n less than 2, return false. Okay. So any number which is less than 2 is not a prime. So we are returning the false. And true 2 is prime. So n double equal to 2, return false. Sorry, 2 is a prime, right? Yeah. From here, for I in range of 3 to that number. So whatever the number that is given, if n percentile I equal to 0, sorry, not 1, I equal to 0 anywhere, it is not a prime. Okay, so we should give like return false here. Yeah. Okay, return false. So there should not be any semicolons required. Yeah. So and at last return true. This case won't reach anyway. So return true. Okay. So consider one thing. So this is not the best prime function in terms of complexity, but time purpose it is fine. So for the initial brute force application, that will be fine. And next one is to print all the prime factors. So def prime factors of n. So prime factors of n. First of all, I mean there are many techniques. So first I will try with n. Sorry, 2. While while n percentile 2 equal to 0, So maybe we can return these prime factors with a list by keeping in a list. But let me put it like print first initially. Later I will, based on the requirement, I will keep it in a list or somewhere. Okay. So for suppose n percentile 2 equal to 0, that means 2 is the prime factor which can evenly divide. So here I will write print of 2. Okay, print of 2, and now I can divide n equal to n integer division of 2. Okay, so this means so that number will be divided with 2. How many times the 2 will divide that? Okay, so this is the first thing, and after that 2 is completed. So we'll get an odd number because it is unable to divide with 2. We'll get an odd number. For suppose take 120. 120 will be divided with 260, 230, 215, and now 15 is an odd number, so 2 won't be divided. We need to start from 3, and there are many numbers, so 3, 5, so the next prime factor should be taken. Okay. Okay, let us go. Let us write a for loop for I in range of 2 is completed. We'll start with 3, and where can we stop this for loop? 3. Maybe can we iterate up to n? We need factors, right? So factors will be like around the square root. So let us take the square root. How to find the square root? We can use the mat dot square root, mat dot sqrt of that number. So mat dot square root of the number will give me maybe some integers. I mean some float values around that n. So let me add +1 to it, and it may give the float value. So let us, so around the square root and +1 around. So we will get the exact value around the square root. So I'm iterating it from starting from 3, and no need of checking for the even numbers because we already did for 2. So we can directly increment the 2. So that means first I will check with 3, 5, 7, 9, 11, 13, so on like that it will check. So yeah, and now while n percentile I, that means starting with 3, 3 may be divided multiple times, right? So suppose take 27, 3 9 is 27, 3 into 3, 27. So we need to do the same process what we did for 2. So if like 64 divided by multiple times, 32, and so on. So in the same way, 3 and the next numbers also need to be divided like that. So I will use this for loop, and if it is double equal to 0, next I will print that I, and n equal to n percentile I. So yeah, so that means so 3 will divide so many times, and when it is not divided, it will go out of the for loop and it increment to 3 to 5. So like that it happens, and at last we'll get some remainder. Okay, so some factor, I mean some prime remainder we will get. So if that is greater than 1, okay, we can print that. At last, if n is greater than 1, we can print that n. Okay, so greater than 1 because 1 is not a prime. So if it is greater than 1, you can increment. Yeah. So this is the prime factors, and this is my prime number. Okay. So now let us try to write the main function. So let us see how we can write the main function to it. So initially we thought like putting an array, whereas indices will represent the number, and indexes will represent the number, and the inner values gives the count. So we will follow the same. So let us go writing main. So I will write the main method with this input later. Just I will take n equal to 53 starting, or n equal to 5 even. Okay, and let us check whether we can get that or not. So it will be easy for us to trace. Okay, so n equal to 5. So I will create a array. Okay, so some sorry, a list. I took a list. Now I need to add zeros to that list up to 5 times. Okay, so 5 is also need to be there because 5 factorial 5 is also included. So for I in range of n plus 1, I will take it as n plus 1, and n plus add I. And plus add I means no, we need to add 0, not I. So we need to add 0. That means 5 zeros. So sorry, 6 zeros will be added to this list. So whereas I will neglect first 0 and 0th index 0 and first index 0. So let us do this. So again, iterate for, so yeah, for I in range of now starts with 0 and 1, remove 0 and 1, neglect 0 and 1, 2 to n plus 1. Okay, and if we already discussed our logic, if given is prime of let me put this capital, so the naming convention is good. Yeah, so is prime of this I. So if it is true, just we need to increment that prime count, I mean that index count. Okay, so L of I need to be incremented by 1. Yeah, and else, yeah, else it is not equal, then I need to call our prime factors function. Prime factors function, uh, sorry, prime factors, I need to send the index I. So yeah, here the I is also sending there, but we are not receiving any array or anything. So let us see. So here we are doing, and we are printing the prime factors. Um, so in order to do that, so I need to get these things what printing here. Or else we can directly increment the count here. Let us see that index, that else count, L of 2 here. Okay, plus equal to 1. And we can do even here L of I plus equal to 1. And at last L of n plus equal to 1. Okay, so let us print our L at the last and see whether we are getting correct answer for 5 or print. Um, so we'll check with custom test case. Then no need to check even for custom test case. Okay, let's run this and check. For 5, we getting some error. This don't have add dot append. Let's try to run this code. Oops, we got 1, 2, 3, 4. We're not getting the correct answer. Let us try to trace this one. Okay, why we are getting this answer? Okay, so prime number. So we're getting 0, 0, 1 and 1. Stretch out. Yeah. So that means for 2, 3, for 4 we are getting 1. Should not get 1 for 4. It should be evenly divided. So there is some mistake with our prime factors, I think. So let us see the prime factors of I. We got here the prime factors. 4 will come here. 4% 2 E double equal to 0. S, which is right. So we are incrementing L of 2, 0, 1, 2, second index plus 1, and n equal to n by 2, which is becoming 2 again. And 2% 2 double equal to 0. Yeah, it should work, but I don't know why it is not working. Let us check only the prime functions, prime factors code once. Okay, let's comment this out. Only check prime factors of 4. Let us see what we are getting. Okay, and just this is how we need to trace. Let us see. So math is not defined. Yeah. Yeah, we got outputs 2 and 2. 2 and 2, which is right. Then why we are not getting the correct answer? So 2 and 2 is right. The prime factor is working correctly. Let us see. on this one. There's some issue with my prime member. Let us cross check. Let us run again. So we took n equal to 5. For 5, we need to get 3, 0, 0, 3, 1, 0, 1. Still I got 1, 1, 1, 1. So this is L of 2. Then I print I. L of I equal to plus of minus 1. That's right. Where it's going wrong. For 4, we got the correct answer. So L dot append zeros. So print out L here. Yeah, right, all zeros. Try to print our L. After every row, we will cross check how our list is changing. Yeah. So we're starting from second index. Second is a prime. It increases its count here. And coming to these two, 3 is also a prime. It's increased here. For 4, it should not increase here. It should increase 2. Okay. So for 4, so it's getting wrong here. Let us cross check. Prime factors we are calling with I. 4 is going there. Is it 4? Yes, 4 is going there. Perfect. Perfect. And coming to top, 0, 1. 4 L of 2 plus equal to 1. It is correct. L of 2. L of 2 plus equal to 1. Where we are not including the count of 4. Why the 4th index is increased? That means my prime. So it is not going to prime factors. I think it is going here. So somewhere wrong with my prime. Is prime. If it is prime, just increment the count. So 2 here prime. So let us check. N less than 2 is not prime. If n equal to 2 is prime, return true. And I equal to 0 in range 3 comma n. If any number divide my n 0, it is not prime. Right? Yes, right. So for prime, let us check whether it's going to prime factors or else or not even. One time it need to go into the room, so it's not going. So some issue with my if statement. If is prime of I, is prime of I is index starting with 2, 3, and 4. 4, it should go 4. Is prime of 4 comes here. No. So is prime of 4. 4. Oh, it should be start with 2, Deepak. Yeah. That's a mistake. Yes, successfully got 310. Yeah. So let us remove all the print statements in between. Yeah. Yeah. We got 3101. Let us see how the format need to be printed. So format is like this. So 5% equal to 311. So whichever is not 0, we need to print that. And we need to read the input also. Let me put a while loop here so that I can read the input. So while true, so because breaking is 0, last time he is doing a 0 for us, so we can use that. And while dot okay. Sorry. I got this. Yes. Perfect. Now I need to print all the non-zeros, which gives me the exact solution. Perfect. So print. Let us write one more method here to string that might be rather than here. Yeah. String. So whenever the string is called, I need to print this n. Okay. So yeah. and I need to print this. So let us write it here, so that it will be a bit easy for me. So print. Rather than that, I can send this input also m comma l, m comma l to push. Okay. Okay. Let me. Okay. Write this as push. App to L comma L. Okay. So we'll take a string s equal to 20. We'll try to append all the things. So like n plus that number plus factorial space factorial space equal to space factorial space equal to space, and we need to append a number comma space. So here L zero and it is equal to that number L of I last s of the column 22 the last minus 1. That is equal to 0. String n plus Java. So typecast. Okay, now we got a none here. Interesting. Let us see. Okay. So we need to rather than run code. So 49, 23, 12, let us cross check. 23, 8, 4, 4, 3, 2, 2, 4, 4, 3, 2, 2, 5, 6, 7 ones. Yes, let me submit and cross check. So here is runtime error. So let us read the question again. So there is one test case we are getting as a runtime error. So runtime error, there may be some edge cases we may getting it wrong. And it filter. So can we read if there are any edge cases that is given what they want to print it? The output formatting consists of several lines. The file will be terminated by a line consisting of a single zero. Output will consist of a series of blocks of lines, one block for each line, and the input. As the input, each block will start with a number n and characters separate. This will be followed with a list of numbers of types. Each prime occurs in a bracket. Each prime should be separated with a comma space. At which case we might get a runtime error. Maybe index out of bounds. I'm using a list here, index out of bounds, or I'm reading the input, maybe input. That's the main problem. So when we're getting these errors, so there is a constraint we can apply 2 less than or 10 less than or 100. So when get up to 100, let me cross it with 100. I'm getting the correct answer. So I'm getting some answer, but I cannot validate it because the factorial is used. Okay, then it's very easy now for me to check why I'm getting the error. Okay, that's better. there is no issue up to 10. Then up to 30. Up to 30 also got. Yes, up to 30 also got. Up to 50 I got, correct. No, I need to take my mental health now. Let's cross check up to 80. No, I'm getting correct answers. Yeah. Already saw. So now I got all the answers right without any errors. Let us call our mentor. Request help. I was unable to see get help option here. So let me stop the screen share once. Yeah, I can see the ask for help here. Clicking ask for help. Invite host. The host has been invited. Let us wait for a minute or two because I'm getting all the answers correct, but maybe some issues with the test case. Let us see. Oh, sorry, here. Hi, sir.
Hi, Devak.
Sir, I was unable to pass all the test cases.
Okay.
Let us share my screen again.
Okay.
Yeah. So only for second case, I got wrong.
Second test case, huh?
Yeah, it's showing runtime error.
Okay.
But I cross-checked all my. You gave the boundary from 2 to 100, the limitation constraint. I cross-checked for all the numbers. I got output for all.
Okay, so let me reveal the second test case. Input 001, right?
Yeah, second means 001.
Okay, Deepak, that might be a mistake from my side. Just hold on.
Yes, sir.
So I have to end the test case with 0 and
oh, okay.
My system is slow on Deepak. Just hold on.
Okay, sir. No problem. Problem is these are not that much stuff. It is making us to think. Like factorial find out chesi cheddam anukunte it might
okay.
Raadu output raadu. అంటే లైక్ టైం అవుట్ రావచ్చు. బట్ అలా కాకుండా వేరే విధంగా ట్రై చేస్తే we will get the answers. Without అంటే ఫ్యాక్టోరియల్ ఫైండ్ అవుట్ చేయకుండా అయితే వచ్చింది.
అవును. దీపక్ ఒక్క నిమిషం.
yes sir.
Second test case కదా input 001.
yes sir, input 001.
No, I didn't add 0 at the last. అందుకని మీకు ఎర్రర్ వస్తున్నట్టుంది.
yes sir.
సో మాన్యువల్ అప్డేటింగ్ కదా ఇవన్నీ అందుకని. సో చెక్ వన్స్ దీపక్ నా రన్ చేయండి అయిపోద్ది.
yes sir. Yes, sir, it's completed now.
Completed, huh? Okay.
Yes, sir.
So you can stop recording and share the URL to